Hello everyone, welcome back to my channel. This is Mr. H. In this video, you will learn how to identify if the given system of linear equations will have parallel, perpendicular, or coincident lines, even without graphing them. Let's recall some information that will be beneficial in identifying each system has parallel, perpendicular, or coincident lines. So if you can recall, the slope-intercept form of any given line is written in the form of y equals mx plus b. And from this form, m represents the slope and b represents the y coordinate of the y-intercept. In addition to this concept, we need to recall some other concepts in order for us to easily identify if the lines will be parallel, perpendicular, or coincident. So for parallel lines, so if the slopes are equal and they have different y-intercepts, which means that b sub 1 must not be equal to b sub 2. So these are the information that we need to consider in order for us to say that the lines are parallel. And for perpendicular lines, so in terms of their slopes, so perpendicular lines will have negative reciprocal slopes, or the slope of the first line will be equal to negative 1 divided by the slope of the second line. For perpendicular lines, okay, the b values won't matter. And for the third one, the coincident lines or coinciding, in order for the two lines to be coincident or coinciding, so technically the concept is you're going to be talking about the same lines here. So with that, the equation 1 will be equal to equation 2, which will lead to equal slopes and equal values of b. So b sub 1 will be equal to b sub 2. And we'll be going back to the concept that, oh, if based on these two concepts, definitely we're talking about, you know, the same exact equations. All right, so these are the concepts that we will be applying in answering the three questions here. For example A, we are given y equals to 3x minus 1 and 9x minus 3y equals negative 5. So earlier I mentioned about the slope-intercept form of the line, which is y equals mx plus b. So that is important because since here we're using the concept of slopes and the values of b, which is the y coordinate of the y-intercept, definitely we need to turn every equation into that form. But before doing that, you can actually do one more thing, which is looking at every equation if the equation can be reduced. When you say reduced, if all the terms in the equation can be divided by a certain number. Going back to example A, you can see that the first equation is already in slope-intercept form. And looking at the second equation, I can see that this is already it. Okay, so you have 9, negative 3, and negative 5. So technically, all these numbers or coefficients and constants definitely cannot be divided by a certain number, right? So that's already it. All right, so for the first equation, y equals 3x minus 1, which is already arranged in slope-intercept form, from here we can say that the slope of that line is 3, b is equal to -1. However, for the second equation, so let's rewrite that. So we have -3y equals -9x minus 5. So divide every term by -3. So -3 divided by -3 is +1, or 1y, or y. -9 divided by -3 is 3, so that's 3x, and negative divided by negative is positive 5 over 3. Okay, so this is now the slope-intercept form of the second equation, and from here we can see that the slope is 3, and the y-intercept, oh no, sorry, not the y-intercept, but the y-coordinate of the y-intercept, or the b value, is 5 over 3. All right, so comparing their slopes and their b values, right? So from what we recalled earlier, definitely the first example, we can conclude that the lines will be parallel. Same slope and different b values, right? Different y-intercepts. Let's head on to the next example. So we were given 7x plus 2y equals -4. So both of the equations are in standard form. Okay? So like what I mentioned before, turning it into slope-intercept form, examine the equation if the equation can be reduced. Looking at the first equation, you've got 7, 2, and -4. Definitely, there is no or certain number that can divide all these numbers, or the coefficients and constant, by, which will give you the exact number. But if you look at the second equation, you get 10y plus 35x equals -20. Looking at the coefficients of x term and y term and the constant, you can observe that this equation can be reduced because all the coefficients and the constant can be divided by 5. 10 is divisible by 5, 35 divisible by 5, and 20 is divisible by 5. So if we do that, so 10y divided by 5 is 2y, 35 divided by 5 is 7, -20 divided by 5 is -4. And if you take a look, this is equation 1, and this is equation 2. So they are exactly the same. So the second equation, if you arrange that, you have 7x plus 2y equals -4. Same goes with the first one. So since the two equations are exactly the same, we can conclude that the the second system, the lines are coincident. So these two equations will give you the same slope, equal slope, and equal, and the same y-intercepts. So technically you're looking at the same lines. So if these two equations are graphed on the Cartesian plane, it will give you the same line. That's why they are coincident. So line 1 will be at the same location as line 2. All right. And for our last example, first equation is y equals 5 over 3x minus 11. And the second one is 6x plus 10y equals 85. So the first equation is already in slope-intercept form, y equals mx plus b, and from here, you can see that the slope is 5 over 3. The b value is negative 11. And second equation, you have 6x plus 10y equals 85. We cannot reduce it, so we can proceed with rewriting it into slope-intercept form. So we got 10y equals negative 6x plus 85. So we divide each term by 10, and we're gonna get y equals negative 6 over 10 is negative 3 over 5, and 85 divided by 10 is 17 over 2. So 85 and 10 can be divided by 5. So it's going to become 17 over 2. So from here, that's already in slope-intercept form. You've got the slope of the second line is negative 3 over 5, and the b value of the second equation is 17 over 2. All right, so let's compare their slopes. So the slope of the first one is 5 over 3, and the slope of the second one is negative 3 over 5. You can see that their slopes are negative reciprocals, right? So it's like the slope of the first line, which is 5 over 3, we just flipped it and multiplied it by negative 1, right? So from there, you can see that the first slope is the negative reciprocal of the second one. Since their slopes are negative reciprocals, therefore the lines will be perpendicular. And based on the concept that we recalled earlier, for perpendicular lines, we're only gonna focus on their slopes, right? Because for their y-intercepts, right, can be the same or can be different. All right, so that's all for this video. If you learned something, please give me a thumbs up and share the video. And if you haven't subscribed yet to my channel, please do subscribe now. And thank you very much for watching, and I'll see you on my next video. Bye.